right, 8.2, raising the flag. A flag ceremony is held at a 4th of July event. The height of the flag is a function of time. Here are some graphs that could each be a possible representation of the function. So they tell me it's a function. Well, let's just double check with our vertical line test to make sure. All right, I only hit the graph one at a time. Same with this one. Same with this one. Here, all right, I'm never hitting 2 points at once, and for that one, I'll use this vertical line to really show that. Never hitting it twice. Same with this graph, never hitting it twice. Same with this graph. And so these are all functions. So this was supposed to be a group activity, but since, of course, we're in a situation where they can't be, I am going to go through all the cases. So for case A, the flag starts on ground level to begin with, and then rises at a constant rate. So let's say maybe this is 5 hours, 5 minutes, 5 seconds, I don't know. But over that time interval, the flag is rising at the same rate. So that's what that graph would represent. That's what would be happening there. Here, it looks like the flag is halfway up. So there's something they call that half mast. When they leave the flag halfway up, they do that a lot on holidays to commemorate people who've died in wars. So that would be this case. The flag is at half mast the entire day. Here, they rise the flag for the first minute, don't move it at all for a minute and a half, then they rise it up again. So maybe they did something to commemorate the veterans, and then after that was done, they rose it up all the way to the top. All right, choice D. That's sort of a bizarre case. This would be if maybe someone was like playing around, like a little kid got hold of the flag and rose it, then brought the flag back down, then brought the flag back up, back down, back up, back down, back up, back down, back up, back down. I've never seen that happen before, but who knows? Here, they rise the flag, keep it at the same height for maybe like if this is a minute, like half a minute, rise it for half a minute, keep it flat, rise it, keep it the same height, rise it, keep it the same height, rise it, keep it the same height. So maybe if this was over 6 seconds, that would be pretty realistic, because I don't know if any of you have had to raise a flag before, but they can be kind of heavy. So if you're taking like in one pull, another pull, another pull, that could take 6 seconds, and it wouldn't necessarily be a constant rate. All right, here, the flag rises at a constant rate, then they change their mind and bring it back down, then they keep it at the same height. I guess that could happen. I would say that if we're talking about realistic and unrealistic, let's mark the ones that are realistic. I would say this is pretty realistic. This is pretty realistic. This could happen. I could see them. I mean, this is, I don't know why they would keep it at the height of 2 and then raise it. So I'm saying that's kind of unrealistic. This one also is like a little kid playing with it. That's pretty unrealistic. This one is pretty realistic. If you were actually pulling a flag up, that would probably be pretty realistic. And this one, I don't know why they would raise it and then bring it back down and keep it at half mast. So I'm gonna say unrealistic for that one. But really, as long as you can justify your answer, you could say any of these are realistic or unrealistic. All right, number 2. Now, if we look at this graph, let's try and see if it passes that vertical line test. And we can see that actually, if I hold my vertical line right here, I've hit every single point in the graph. So for my 1x value, where x is 3, I have infinite y values. So this is not a function. So I'm going to answer B first. Not a function. It does not pass the vertical line test. All right, so what does this really mean in real life? What would have happened here? Well, this would mean at 3 seconds, the flag was at a height of 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet, all at the same time. So it's not possible to be infinite different amount of places at one time, right? I can't be at home and at school. Well, actually, technically we are all at home and school at the same time. I can't be at home and at McDonald's at the same time, right? That would be impossible. You can't be in two places at once. This is another reason why it sort of makes sense that this is how we define a function. Because most of the time we have time on the x-axis. And if I have one x value and two different y values, that means I'm in two places at the same time, so it can't be true. So I can say, no, the flag can't be more than one place at a certain time. All right, we are not going to do Are You Ready for More for this, since it's totally unrelated to this unit. So we are going to stop here at number 2.